Welcome to Ask and Learn.
We will sketch the graph of the function exponential of x and use that graph to find the absolute, local, maximum, and minimum values of the function. So we know that this exponential function is equal to 1 at 0. It is increasing, always increasing, it's always positive. It increases quickly, and when x is large but negative, that is, if we move on the graph to the left to negative infinity, the values of the function are closer and closer to 0, but always positive. It means that the graph of this function is more or less like this. We have an asymptotic behavior to the left, and then we have an rapidly increasing behavior to the right. Here we have the value 1 at 0. So this is more or less the graph of the exponential function, and we see clearly here that the limit when x goes to plus infinity of the function is plus infinity. It means the function grows without any bound when x is large and positive. It means the graph goes up when we move to the right of the graph goes up, and that without any bound. And the other property is that the limit when x goes to minus infinity is 0. And that means that the function is getting closer and closer to 0 when we move to the left of the graph. That is, when we make x large but negative. And here we are considering the function defined on the whole real numbers, because there's no other specification in the statement of the problem. So we are considering the whole real numbers as the domain of the function. And we have then these two properties. Then with that, we can say that there is no a highest point in the graph, because the graph is always getting up to the right, and because it has an asymptotic behavior near 0, that is approaching the value 0 when x is large and negative, we can say that when we move to the left of the graph, the function is always approaching 0. That is, it does not have as lowest possible value. For those reasons, we can say that f has no absolute extrema. That is, no absolute maximum, no absolute minimum at all. And for a similar reason, that is, there is no point where that can be considered the highest value near or locally, and the same thing for the minimum. So the f has no local extrema at all. So we can say the two things together, that this function has no extrema at all. And the main reason for that is this behavior here of always getting closer and closer to 0 when we move to the left, and growing up without any bound when we move to the right, and the function is always increasing, positive increasing function. And so the consequence of that is that the function has no extrema at all, and that's the exponential function.